Okay, my dear students, we have to discuss about the another topic is atoms in our second year physics. So before going to this topic, I have to tell us about the what is the atom, what are the atomic models, which scientists are find out the atomic models. First one is the atom. Atom contains equal amount of positive and negative charges, means, and the atom is in neutral state. So what are the atomic models? We have to take out J.J. Thomson atomic model, and next one Rutherford atomic model, then last one Bohr's atomic model. So first we have to learn about the J.J. Thomson atomic model. It is also called Thomson atomic model. In this Thomson atomic model, the total every atom we have to take into amount of positive and negative charge. In the same manner, in Thomson atomic model, the positive charge is distributed over all the atom, means we have to take in any atom, the total positive charge is distributed over the atom, and the electrons are embedded in it like seeds in a watermelon. So this Thomson atomic model is compared to a watermelon. When we are observing any atom, the atom is totally distributed over with the positive charge, and let we take and compare to watermelon. In this watermelon, the seeds are the negatively charged particles, means electrons, and remaining amount of substance is equal to positive charge. So according to Thomson atomic model, there are 2 points are important points about the atomic model. The first one is the atom consists of positively charged sphere with electrons embedded in it, and the second point is the atom as whole is electrically neutral because the negative and positive charges are equal in magnitude. These are the main 2 points in the Thomson's atomic model. So this Thomson atomic model is compared to a watermelon. So what are the comparing of the points of the watermelon? When we are observing the watermelon seeds as negatively charged particles. Seeds are the negatively charged particles, means seeds are the electrons in the atom, and the red part of the watermelon means remaining amount of material substances as compared to as a positively charged. So when we are observing this Thomson atomic model, in this Thomson atomic model, this is the atom. This atom is compared to watermelon. So this atom have positive and negative charge. In the same manner, this watermelon seeds are the electrons, and remaining amount of substance is equal to positive charge. So in this Thomson atomic model, some drawbacks are there. So the limitation of Thomson atomic model, the first one is it could not explain the spectral series of hydrogen atom. So hydrogen atom spectral series are not explained by the Thomson's model. And the second one is the Thomson model failure to explain the scattering of alpha particle by thin metal foils. This drawback is explained by the Rutherford model. So, and the third one is the no experimental evidence in support. So these are the drawbacks, are the demerits of the limits of the J.J. Thomson atomic model. So we can rectify this demerits, and next we have to go to the Rutherford atomic model. In this Rutherford atomic model, first one is the first postulate is the atom consists of a small central part, means when we are observing any atom, the atom as a center point, the center point as a central part, the part is called nuclei. This nuclei have some mass and some charge. So according to Rutherford model, the atom consists of a small central part is called nuclei. Atom's central part, this is the central part, is called nuclei, and this nuclei have the total mass and whole positive charge of the atom is concentrated at the nuclei, means the nuclei have some mass and the nuclei charge is positive charge. So this is the explained by the Rutherford. So what is the meaning of nuclei? So nuclei means, when we are observing this diagram, the nuclei have protons and neutrons. So the combination of protons and neutrons is called nuclei. The nuclei charge is positive charge and electrons are revolves around the nuclei. So second point is, according to Rutherford model, the size of the nuclei, when we are observing the nuclei in the atom, so the size of the nuclei, this nuclei size is equal to 10 power minus 14 meters or 10 power minus 15 meters. So we can observe the nuclei in the atom. So the atom size, the size of the atom is equal to 10 power minus 10 meters. So next one is, the most of an atom is empty space, and next one is the negatively charged electrons are around the nuclei in circular orbits. So when we are observing this diagram, in this diagram, this is the nuclei, and this nuclei have protons and neutrons, and the electrons are the revolves around the nuclei. So then last one is, the total positive charge on the nuclei is equal to, so the charge of nuclei is positive charge, so the total positive charge of the nuclei is equal to, equal amount of charge is equal to negative charge on the electron. So means, therefore the atom as whole is electrically neutral. And there are also some drawbacks, demerits of the Rutherford atomic model. So they are, the first one is, the it could not explain the stability of the atom, and also it failed to explain the radiation spectrum of atom. These are the drawbacks of the Rutherford atomic model, and these drawbacks are overcome by, we have to take into another model. The model is Bohr's atomic model. So before going to Bohr's atomic model, there are some postulates about the Bohr's theory. So first one is the J.J. Thomson atomic model, and second one is the Rutherford atomic model, then third one is the Bohr's atomic model. According to Bohr's theory, Bohr's atomic model, the first one is, the electron revolves around the nucleus only in certain stable orbits without radiating energy. Means, when we are observing any atom, this atom consists of nuclei, the nuclear charge is positive charge. In this figure, we have to observe the electron charge is negative charge. So negative charge particle, electron is revolves around the nuclei in certain stable orbit without emitting, without radiating energy. So this is the first postulate of Bohr's theory. And the second one is, the when electron is revolves around the nuclei, means the electron is in angular velocity, means it have angular momentum. So the revolving electron angular momentum is quantized, means the electron revolves only in those orbits for the which angular momentum is integer multiple of h by 2 pi, where h means Planck's constant. So electron's angular momentum is equal to L is equal to mvr is equal to nh by 2 pi, where n is the number of the orbits. And the next point is the last one, when electron jump from a higher energy state to lower energy state, the difference of energy appears in the form of photons energy. So we can observe this diagram, higher energy state to E2, it can jump from higher energy state to lower energy state. So the lower energy state is E2. The difference of energies E2 minus E1 is equal to, in the form of photons energy. So the photons energy is h nu. So we can observe this diagram. This is the nuclei, this is the first orbit and second orbit, third orbit. When an electron jump from second to first, So E2 minus E1 is equal to h nu. This is the third postulate. So first one is the electron revolves around the nuclei in certain stable orbit without radiating energy, and second one is the electron revolves in certain stable orbit, the angular momentum must be quantized. Then third one is the when an electron jump from higher energy state to lower energy state, they can emit the energy is in the form of photons energy. So we can observe the hydrogen spectral series. So hydrogen spectral series are 5 types. So the following different types of spectral series observed in the spectrum of hydrogen atom. So first one is the Lyman series, second one is the Bohr series, third one is the Paschen series, fourth one is the bracket series, then last one Fund series. We can observe this series are when first one is the Lyman series. The electron can jump from higher energy state to lower energy state. In this all above series are formed by the because of they can emit the energy from electron can be jump from higher energy state to lower energy state, then the series will be formed. So first one is the Lyman series. So the spectral lines of this series correspond to the transition of an electron jump from, we can observe this point is very important one, the electron jump from higher energy state to the innermost orbit, means lower energy state, that is n is equal to 1. So then the Lyman series will be formed. So for Lyman series n1 is equal to 1, this is the lower energy state, innermost orbit. N2 higher energy state, more than 1 means 2, 3, 4 up to infinity, these are the higher energy state. The electron can be transition from higher energy state to lower energy state. The lower energy state is innermost orbit, n is equal to 1, then the Lyman series will be formed. So this series lies in the ultraviolet region. In the same manner we can observe the Bohr series. The spectral lines of this series correspond to the transition of electron can jump from some higher energy state to the innermost orbit, that is n is equal to 2, means the n is equal to 2 means n1 is equal to 2 is the innermost orbit, means lower energy state, more than 2 means 3, 4, 5 are the higher energy state. So the electron can be jump from 3 to 2 or 4 to 2 or 5 to 2. So it can form the Bohr series. So this series can be lies in the visible region. Same one manner Paschen series. In the same one, the electron can be jump from higher energy state to innermost orbit, that is n is equal to 3. So for we can observe the higher energy state are the more than 3 means 4, 5, 6 up to infinity. The innermost orbit is the 3. So this series lies in the infrared region. Next one, bracket series. Same manner the electron can be jump from higher energy state to innermost orbit. The orbit is equal to n is equal to 4. So what are the innermost orbit where n1 is equal to 4, n2 is equal to more than 4 means 5, 6, 7 up to infinity. So this series lies in the infrared region. The last one, Fund series. So the spectral lines of this series correspond to the transition of an electron from some higher energy state to innermost orbit. The innermost orbit is 1. So more than where n is equal to 5, we have to take n to 1, sorry. So n1 is equal to 5 and n2 is equal to 6, 7, 8 and above up to infinity varaku. So the electron can be jump from higher energy state to innermost orbit. So this series lies in infrared region. So we can observe this diagram. There are the 5 series. First one is the Lyman series, and second one is the Bohr, then third one is the Paschen, and fourth one is the bracket, then last one is the Fund series. We can observe that n is equal to 1 innermost orbit Lyman, n is equal to 2, innermost orbit, bomber. N is equal to 3, innermost orbit means lower energy state, passion. N is equal to 4, bracket series. N is equal to 5, passion series. So these are the spectral series of the hydrogen atom. And so we can observe these 5 series are available in observing some regions. So first one is the Lyman series can be lies in observed in ultraviolet region, and Bohr series can be observed in visible region, and Passion series observed in lies in infrared region, and bracket series lies in infrared region. In the same manner, Fund series lies in infrared region. So these are the spectral series and lies formation of observed in the regions. So the next one is the limitation of Bohr's theory of hydrogen atom. So what are the limitations, drawbacks of the Bohr's theory of hydrogen atom? So the first one is the Bohr's model is applicable to hydrogenic atoms, means Bohr model is applicable to only hydrogen atom. That means the atomic number of hydrogen Z is equal to 1. So this model is unable to explain the relative intensity of the frequencies of the spectrum. In the same manner, it could not explain the Zeeman effect, and also it could not explain why the angular momentum is quantized. And next one, it could not explain Stark effect, and it could not explain why electrons are orbiting only in circular path. The last one is the Bohr's model presents an elegant picture of single electron atom and cannot be generalized to complex atoms. So these 7 points are the limitation of the drawbacks of the Bohr's theory. And the next one is the kinetic and potential energy of electron. When an electron revolves around the atom is hydrogen atom. So we can observe this, we can derive the equations of kinetic energy equation and potential energy equation. So kinetic energy, generally kinetic energy equation, it is represented by K is equal to half mv square. For we can derive the kinetic energy, we can observe the atom. When an electron revolves around the nuclei on orbit, the electrostatic force, means the electrostatic force between electron and nuclei, the force is called electrostatic force, is equal to centrifugal force. So we can observe that Fe means electrostatic force is equal to centrifugal force Fc. So the electrostatic force by Coulomb's law. So we can observe the Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where instead of Q1 Q2 we can take charge of nuclei, charge of electron, E. So 1 by 4 pi epsilon naught E into E by R square, and the centrifugal force is equal to the magnitude value equation mv square by R. So next one, 1 by 4 pi epsilon naught E into E. So we can product the charges, E square by R square is equal to mv square by R. So let one, where we can observe the denominator, where the mv square by R will be cancelled to square R. So 1 by 4 pi epsilon naught E square by R is equal to mv square. Multiply with 1 by 2 on both sides. So 1 by 2 mv square is equal to 1 by 2 1 by epsilon naught E square by R. So 1 by 2 mv square is equal to 2 into 4 is equal to 8. So 1 by 8 pi epsilon naught E square by R. Therefore, where half mv square is equal to kinetic energy, so the kinetic energy represented by K is equal to 1 by 8 pi epsilon naught E square by R. So this is the equation number 1. This equation tells about the kinetic energy of an electron when electron revolves around the hydrogen atom. So K is equal to 1 by 8 pi epsilon naught E square by R. So we can calculate also the potential energy. So the potential energy of an electron, this is the simple method, U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. This is the common equation, potential energy. So according to electrostat, so where Q1 Q2 is the, we can take charge, nuclear charge and electron charge. So u is equal to 1 by 4 pi epsilon naught, where E is the positive E, positive charge, this is the nuclear charge, and minus E means electron charge, this is the negative charge. So E into minus E by R. So we can multiply with E and minus E. So u is equal to minus 1 by 4 pi epsilon naught E square by R. So the potential energy term is positive term, and the kinetic energy term is positive term and potential energy term is negative term. So we can observe that there is a relation between the u and R. R is the radius and the u proportional to minus 1 by R, means when n is increases, n is means number of orbits increases, then also R will be increases. We can observe this diagram. This is the nuclei, positive charge. First one is the n is equal to 1, means now first orbit, n is equal to second orbit. So when orbit level is increases, means n value is increases, then also the radius also increases. We can observe the relation between potential. So the potential u is also increases. So this is the potential energy and kinetic energy equations. Kinetic energy equation is K is equal to 1 by 8 pi epsilon naught E square by R, and potential energy equation u is equal to minus 1 by 4 pi epsilon naught E square by R. And the next one is the de Broglie explanation of Bohr's second postulate of quantization. So what is the second postulation of quantization? Electron's angular momentum is quantized. So this property will be explained by the de Broglie. So the de Broglie explained that the moving electron in its circular orbit create a stationary wave with nodes and antinodes. So we can observe the electron revolves around the nuclei, and when the electron revolves around the nuclei, it can form a stationary wave, and we can observe that the stationary wave have nodes and antinodes. So the stationary wave, the total distance traveled by a wave, means this is the nuclei. We can observe this diagram. This is the nuclei. When an electron revolves around the nuclei, it can form a stationary wave. It have nodes and antinodes. In the same manner, when an electron revolves around the nuclei, it can completed by one round, and the circumference of the electron, means the total traveled distance is integer number of wavelengths. So in the same manner, the circumference of the electrons, means C is equal to 2 pi R is equal to n lambda. So for an electron moving in nth circular orbit, the radius is Rn. So the total circumferences, total distance traveled by the electron is 2 pi R. So 2 pi R is equal to n lambda. So we can observe it can imply to lambda is equal to 2 pi R by n. This is the equation number 1, where lambda is the wavelength. In the same manner, we can observe that if speed of electrons in nth orbit, the momentum p is equal to mv, where m is the mass of the electron, v is the velocity of the electron, according to de Broglie wavelength. So the de Broglie wavelength equation is lambda is equal to h by p, where p is the momentum. So we can substitute mv. So lambda is equal to h by mv. This is the equation number 2. So from equation 1 and 2, 2 pi r by n is equal to n h by mv. So mvr by n is equal to h by 2 pi. So therefore mvr is equal to nh by 2 pi, where mvr is the electron's angular momentum, L value. The L is equal to mvr is equal to nh by 2 pi. So electron angular momentum is quantized. We can observe this figure. This is the nuclei. This electron will be revolves around the nuclei. It can form stationary waves. C is stationary wave have nodes and antinodes. So we can take this one. Wavelength is the lambda. Lambda is equal to h by p. This is all equal to h by mv. So we can observe the electron traveled distance is equal to circumference of the circle. So 2 pi r is equal to n lambda. So we can calculate and conclude equation L is equal to mvr is equal to nh by 2 pi. So in this chapter we have to learn about the atomic models. What are the atomic models? First one is the J.J. Thomson atomic model, and second one is the Rutherford atomic model. Then third one is the Bohr's atomic model. In Bohr's atomic model we can learn about the postulates of Bohr's theory. In the same manner, spectral series of hydrogen atom, and also we have to learn about the limitation of the drawbacks of the hydrogen atom according to Bohr theory. And next one is the we can calculate the kinetic energy and potential energy of the electron around revolves around the nuclei. And then last one is the de Broglie explanation of Bohr's second postulation of quantization.